Hello everyone. Today we are going to see about data structures, like what they are, why they are important, and also their types. I will also explain linear and non-linear types. In linear category, I'll be covering arrays, lists, stacks, and queues. And for non-linear category, I'll be talking about trees and graphs. Here's the definition for data structures. And data structures are the ways to organize and store data so that the data can be used efficiently. So what is the need for data structures? It helps to store data in a structured way and makes searching and processing more faster. Simplifies sorting and store large amount of information, and it is essential for apps, games, and also for databases. The type of data structures are primitive and non-primitive. In primitive, it is divided into int, char, and float types, and in non-primitive, it is again divided into linear and non-linear type. Linear type is a type where the data elements are arranged in a sequential manner, and in a non-linear type, the data elements are arranged in a hierarchical manner. Linear data structures are again divided into linked list, stack, queue, and arrays, and non-linear types are divided into trees and graphs. Let us see what are they. Coming to arrays, arrays are collections of elements identified by index. So let us consider an array named as ARR, which has 5 elements or items into it. For an array, the indexing starts from 0. In the given array ARR, there are totally 5 elements indexed from 0 to 4, and the first element of the ARR is equal to 3, as the indexing starts from 0, and the third element is 7. In an array, the memory is allotted continuously to store data. In a linked list, we can store data in different locations. Here the memory allocation is dynamic, whereas in an array the memory allocation is continuous. If we need to store values in certain location, then how does the system index the number, whether it is in this particular location, like that? Here the node stores both data and address of other node to link the next node. Here you may notice that the node contains both the data as well as the address of the next node. Here the first node provides the address of the second node as 113 and links both the nodes, and the second node provides the address of the next node, and the data can be accessed. If suppose the address is null, the address to the next node will be lost and the link is cut here and will be not able to access the data after that. Now for a stack, let us consider this as some web pages, and if we click the enter link, it will be added to stack one by one, and if we click the back button, we can take out the stack's first element. So here the last entered data is processed first. It follows last in first out arrangement. The insertion operation is called as push and the deletion operation is called pop. Here I have given cross mark for the last data as it is processed first, followed by the previous ones. Queues are just opposite to stack as it follows first in first out principle. For example, a person standing first in the bill counter will settle the bill first, followed by the next one. Here the insertion operation is NQ and the deletion operation is DQ. Stack and queue can be implemented using array and linked list. Now we'll move on to the non-linear type, whereas the data elements are not arranged sequentially but in a hierarchical manner. A tree is a hierarchical structure where each node possesses a parent node and multiple children node. Consider this hierarchical family structure. If the node ends here, it is called as leaf node. In a tree, a node possesses the data, the left address and the right address. Hence it is called as a binary tree. Here 210 is the left address and 211 is the right address. Next nonlinear type is a graph. It is used to represent relationships and contains both vertex and edges. Here I have named the vertices as 1, 2, 3, 4 and 5 and the edges as 1 to 2, 3 to 4, 5 to 4 and 2 to 3. Consider the vertex as a node or location in a graph and the edges as a path to connect the vertices. Now I have connected the vertices by the edges, which serves as a path to connect both vertices. Here is a programmatical representation by matrix. So as I have considered 5 vertices, I am using a 5 cross 5 matrix. As we are having path for 1 to 2, I am going to write 1 wherever we have path and I will fill the remaining boxes as 0. Through this method, we can easily access the path of nodes. This representation is named as adjacency matrix. So these are the basics of data structures. Thanks for watching.